share the driving between two cities 2,000 miles apart. Which of the cities drove the greatest distance on the trip? The question's theme states that the total distance was 2,000 miles. Branko drove X miles, Queenie drove Y miles, and Norman drove Z miles. X plus Y plus Z, 2,000 miles. We want to know which of these variables is the greatest. So, statement 1 alone says Branko drove 2 hours longer than Queenie, but an average rate of 10 miles per hour slower than Queenie. We get the following. If Queenie drove for T hours, Branko drove for T plus 2 hours. If the rate of Queenie is Q, the rate of Branko is Q plus 10. However, we do not have information about Norman. Therefore, statement 1 alone is not sufficient. Alternatives A and D are eliminated. Now let's go ahead with statement 2. Norman drove 10 hours and averaged 65 miles per hour. Therefore, Z equals 65 times 10. The distance Norman traveled was 650, which means that the distance Branko and Queenie drove together was 2,000 miles minus 605,000 miles. This is 1,350 miles. However, we cannot determine which of the variables is the greatest. It can be either Z, X, or Y. So, statement 2 alone is not sufficient. Alternative B is eliminated. Now we need to use both statements together in order to know if we can answer the question or not. So from statement 1 and 2, X plus Y is this number, and we have an equation. X can be written as the rate of Branko times the time of Branko. So we get X plus Y equals Q plus 10 times 10 plus 2. And Y is Q times T. And the sum of this expression must be 1,350. However, this is an equation with two variables. We cannot determine the value, either the value of Q or T. Therefore, both statements together are not sufficient to answer the question. Alternative C is eliminated. Choice E is correct. After winning 40% of the first 60 games it played, Team A won all the remaining games it played. How many total games did Team A win? So, according to the question's theme, %40 of the first 60 games they played were won, 24. Now, they also state that Team A won all the remaining games it played. Now, let X be a number of games they played after the 61st games played. All of them were won. Therefore, the total number of games won by Team A must be 24 plus X. We need to find the value of the sum. Now, from statement 1 alone, Team A won 15 of the last 18 games it played. Now, since we don't know where the last 18 games they played lie at, for instance, the last 18 games, if X is 15 for instance, then the last 18 games might be here. And the total number of games played, the total number of games won would be 24 plus 15, 39. But what about X being, for instance, 12? Then the last 18 games would be right here, and 3 of them that were won would be part of the 24. Therefore, the total number of games won would be 24 plus 12, 36. Now, since we have two different answers, statement 1 alone is not sufficient to answer the question. Choice A and D are discarded. Now, from statement 2 alone, Team A won 18 of the first 52 games it played. So, for the first 52 games played, 18 were won. But we know that out of the first 60 games, 24 were won. So, we don't need statement 2 to answer the question, since we have no information about X. Statement 2 alone is not sufficient. Choice B is discarded. Now, we need to use both statements together now. From statement 1 and 2, statement 2 was not important, and we know that statement 1 didn't lead us to the answer. Therefore, both statements together are not sufficient to answer the question, because the value of X is still unknown. Finally, choice C is discarded. Choice E is correct. We need more information. How many 360-degree rotations did a bicycle will make while rolling 400 meters in a straight line without slipping? So, in order to find the answer, we need to know the time the bike traveled and how many rotations per minute or seconds or hours it did. From statement 1 alone, the wheel made 12 rotations per minute. Now we know the rate for rotation. Rotations, they were 12 per minute. However, we still don't know how many hours or seconds or minutes the bike traveled. Therefore, statement 1 is not sufficient to answer the question. Alternatives A and D are discarded. Now, from statement 2 alone, the wheel rolled the 25-meter distance in 13 minutes. Now we know the rate of the bike, and that was 25 meters per minute. However, we don't know still how many rotations per time the bike did. Therefore, statement 2 alone is not sufficient. Choice B is discarded. Now, we need to use both statements together. From statement 1 and 2, we know the rotations, the rate for the rotations, and the rate of the bike. So, since the wheel does 12 rotations per minute and its rate is 20 meters per 13 minutes, then the distance, which was 400 meters, is equal to the rate times the time. Now, the time that the bike traveled is 208 minutes, and the number of rotations is equal to the rate for the rotations, 12 rotations per minute, times the time it traveled, and it was 208. Therefore, we need both the statements in order to answer the question. Alternative E is correct, choice C is correct.